Hello everyone, this is the first video of class 11th in which I will be teaching you the first part of mechanics, which is kinematics. Now you will think, sir, why not unit dimension and basic maths? The reason is I want to start with kinematics and I want to go in a sequence: kinematics, NLM, friction, circular motion, work energy, center of mass, rotation, and so on. I want to go with this trend, starting with mechanics. Unit dimension and basic maths, I will make a separate playlist. Those videos will be coming in between, no need to worry. But as right now most of the school and coachings are in mechanics, I want to start with mechanics. Clear? Now what is this mechanics? This mechanics is a very big branch in physics in which we have to deal with the things going around us, the forces and the effect of forces. For example, if I kick a ball, so I am applying a force on the ball. I am giving a cause, a force. Because of that force, what will happen? Because of that, the ball will move. When the ball will move, what are the effects on the ball? What effects you will see? You will see that there will be a change in speed of the ball. The ball will cover some distance, some displacement. Ball will have some speed, velocity. How the velocity in x will change, how the velocity in y will change, what is the acceleration acting on the ball, what will be the range, how much the displacement ball will cover, what will be the time of flight of the ball, at what angle the ball is shoot, how the angle is changing, all those things. So these are the effect. I apply the force, that is the cause, and what that cause has done, that cause has created an effect on the body. Study of that effect is known as kinematics. I know from your seniors you have heard that this mechanics is very difficult, but trust me, if you want to crack advance, if you want to get the actual feel of physics, you should be good in mechanics. And if you want to be good, you have to practice problems. You have to get the feel. You have to connect the things with the surrounding. The very best part of mechanics is we can connect, we can feel. In class 12th, we have to deal in quantum level. So getting that feel is a bit difficult, but here you can. And trust me, if you got interest in mechanics, you will feel physics to be really interesting. You can relate everything, whatever is happening around you. So I will go very slow. I will teach you every concept, all types of problem. I want you all to pay attention. Okay? Because mechanics, they can connect with any of the chapter. In class 12th also, I can take any chapter and I can connect with this mechanics. Is it clear to everyone? Understood? So what is mechanics? It's a branch of physics in which we have to deal with force and effect of force. First, I'm starting with kinematics. This is the first part of mechanics. In kinematics, we have to deal with effect. What effect a force will create? If you look at the term kinematics, it is made up of two words. You can see kine. Kine means motion. Then we have second term, matics. Kinematics. Matics means motion. Sorry, matics means maths. So basically we have to deal with mathematical terms when a body is in motion, like distance, displacement, velocity, speed, acceleration, jerk, all these terms. Clear? So before starting, I want you all to tell me what is this motion or what is rest. Let's say right now I'm standing here. Okay, you tell me I'm at rest or I'm at motion. Most of you thought, sir, you are at rest. But tell me one thing. Right now, I am on earth in my room, standing here in front of you all and shooting a video. You are saying, and you are somewhere here and seeing this video. You will say that, sir, you are standing still, you are at rest. Fine. But you tell me, if someone is observing, let's say, if some alien is observing me from outside, what he will see? He will see that the earth is spinning about its own axis as well as around sun. So earth is rotating as well as revolving. So what this alien will see? This alien will see that sun is rotating as well as revolving. So the alien will see that sun is in motion. Yes or no? So see, it's senseless to ask that either a body is in rest or motion. Is it? We have to specify from whose frame I am asking. By default, if frame is not mentioned, we take ground as the frame. That I will talk after some time. What is this frame and all? So here, I think you all got the feel. Sir, we cannot say that a thing is at rest or motion. There is nothing like absolute rest and absolute motion. For you all, right now, I am at rest. But for an alien outside the earth, I will be in motion. Is it? Is it? Just pause and draw this diagram just for your understanding. Okay. Next, let me take one more example. For example, let's say this is a car and you are standing here. You are at rest on ground. You are on ground and you are at rest. Let's call this person as D. A person A is moving in a car with 20 meters per second. A person B is also sitting on the car. Clear? And a person C is also there, and this person C is going left with a speed, or let's say he is also going right with a speed of 20 meters per second. And let's say one more person is there here who is going left with 30 meters per second. This is person A, B, C, D. This is person E. Okay. If I ask you, what will be the velocity of A? You will say, sir, 20. But 20 is not the correct way to give the answer. Why? If B will see A, now let's say you are sitting in a car, you are driving the car. Your friend is sitting on the next seat. You are driving the car. When you will see your friend will be at rest. And when your friend will see you, he will also find out that you are at rest. So from B frame, A will be at rest. Or from A frame, B will be at rest. So can I say from B frame, A is at rest? Yes or no? What about D? How D will see A? You are standing on a ground, a car is going with 20. What you will see? At 20. So D will see that A is going forward with 20. So for D, A is going with 20 meters per second in right direction. Correct. What about C? What C will feel? C will feel that C is going with 20. A is going with 20. Have you observed when you go on a bike, suppose your friend come and you both talk and move, you both talk and drive your cycle or bicycle, whatever. So when you will see your friend, you will feel that he is at rest. When you both go with the same speed, you feel that your friend is at rest. And same, your friend feel that you are at rest. Yes or no? So what C will feel? C will feel that A is at rest. So for C also, A will be at rest. What about D? Look at D. Look at E. E is going left. A is going right. Have you observed when two car crosses in opposite direction, it seems that other car is going very fast. Is it? And when two car, if let's say this is car 1, car 2, if car 2 overtakes car 1, when you look outside, the car which is overtaking seems to be overtaking slow. But from ground, that car is going very fast. Are you understanding? So for E, as E is going left, A is going right, E will feel that A has went very fast. Very fast. What speed we'll discuss in relative velocity, no need to worry. So what I am saying you here, that this person A is having different speed from different point. For different object, the speed of A is different. It means for different object, A is doing different type of motion. Yes or no? If I take one more, let's say if I take F, and this F is going with 80 meters per second. So when you are going in a car very fast and you overtake a car, what you feel that you are at rest, the car on the side is going back. So what this person F will feel, as F is going very fast F will overtake A. And what F will feel that A is going back. Yes or no? At the same time, this person on ground has seen A going forward. How A will see D? How this person A will see D? A will feel that, okay, I'm moving in a car. When I see outside, I feel that the things which are outside, buildings, whatever trees, whatever is outside, I feel that that is going back. So what A will feel? That D is going back. Is it? Everything goes back. So every particle here is doing a different type of motion with respect to other particle. No need to worry what will be the speed and all. We'll discuss in detail. Relative velocity we'll discuss. I'm just showing you here that a particular body can be in different direction with respect to different direction, different speed with respect to some other body. Is it clear? Understood? So A was at rest with respect to B. But A was going forward with respect to D. But A was at rest with respect to C. A was going very fast with respect to E. And with respect to F, A was going back. Is it clear to everyone? Understood? So from here I can conclude that rest and motion is not absolute. You might feel that a particle is at rest from one frame. At the same time, from the other frame, you will feel that the particle is going forward. And at the same time, from a third frame, you might feel that the particle is going backward. If you want, you can pause and write. I just gave this to make you understand that motion and rest are what? Not absolute. They depends upon frame. From which frame you are observing, from which frame you are seeing the object. If I ask you a simple question, very simple question. Just imagine A is going with 30 meter per second forward. This is B. B is going with 60 meter per second. This is also going right. Okay. Then we have C. C is going with 80 meter per second. And then we have D. D is at rest. I want you all to tell. No need to write this. Just tell me this part. Look at, we will focus on B. B is going with 60. Let's say you are observer. You are A. You are going with 30 and someone is going with 60. Let's say you are sitting in a car going with 30 and B is overtaking you with 60. So when you will look outside to car B, you will feel that B is overtaking, B is going forward. So for B, so for A, we are observing B. For A, when A will look B, B is going forward. So B is moving forward with respect to A. Same, I will look at B from C frame. Now B is going with 60. I am C. I am going with 80. So I will overtake. So when I will look out, I will feel that, okay, I am not moving. B is going back. I am C. I am going faster. So when I will overtake B, I will feel that I am not moving forward. That B is going back. So for C, B is, so I can write like this. B is moving backward with respect to C. And for D, it's going forward with 60 because D is at rest on ground. Now if I say we have one more person E, and this person E is going with 60 meter per second. Now when E will look at B, what E will feel? E is going with 60, B is going with 60. Both will go together. So when this E will look at B, E will feel that B is at rest. So this is at rest with respect to E. And with respect to this D, he is going with 60. So I showed you that this person B can be at rest from one frame, can be moving forward from one frame, can be moving backward from one frame, and from all these three frames, they will not see 60, they will see something else. That I will discuss, no need to worry. And this D will see it's going with 60. So from all the frame, the body is having motion in different direction and also with different speed. I hope you understood, you got the feel of motion and rest. Is it? Clear? I will give you a practical example. I hope you have traveled through train. Let's say your train has reached to some station, it's standing on platform, on a railway track. Okay. Now on the right of you, let's say one more track is there. There also one train is at rest. Now that train start to move. When you look at that train, you are confused. That train is moving or your train is moving. So to confirm, you see left to the platform. If platform is at rest, it means your train is not moving, that train is moving. And if platform is going back, then you get confirmed that okay, my train has start to move and that train is at rest. Have you observed that? This is what? Relative velocity. Is it clear? Fine. You can pause and write this. Okay. Next. Next is reference frame. Reference frame. From the last 10 minutes, I am saying something like frame, frame, frame. What is this reference frame? Reference frame is that frame from where you are observing the object. Basically, you have to become a lizard. You become a lizard, and you stick to the frame, and observe the object. Clear? So basically what I am saying, reference frame is that frame from which we observe the object. Okay, so you have to go to that frame, become a lizard, stick to that frame and observe the object. Clear? The frame from which we are observing the object is known as reference frame. Clear? Pause and write. Next. So from here, what will be relative property of motion? What I can say from here? Can I write some points? Point number one. Motion is a combined property. Motion is a combined property of object and observer. Object and observer. Is it? Both has to be defined. Clear? Second, there is nothing like absolute motion and absolute rest. Is it? And third is motion is only defined with respect to observer. You have to define observer. But keep in mind, suppose a question came, they ask what is the velocity of this, whatever. Keep in mind, if they have not specified who is the frame, where is the observer, you have to take by default ground as the frame of reference. You can write on the top, by default ground is the frame of reference. Clear? You can pause and write this. So from here, how can I define motion? I want you all to write by yourself. Motion is basically change in position with respect to time and it depends upon frame of reference. What is motion? Motion is change in position with respect to time and it depends upon frame of reference. Clear? Pause and write. Okay. Now, don't be confused in two terms. First, frame of reference. Okay, and second, reference point. These two are different things. Frame of reference means that frame from which I am observing an object. Let's say if I say the frame of reference is ground, Ground is the frame of reference. It means I am observing the object, motion of an object from ground. But what is this reference point? Reference point is that point from where I take the measurement. From where, this is from where I can take the measurement. For example, if I say that what will be the velocity of this car from ground frame? Now frame is fixed. From anywhere of this ground you can tell the velocity. If I say the car is going with 40 meter per second, so you are at any place on the ground, you will say speed is 40. But reference point, let's say I told that reference point is here. Here is the reference point on the top of the car. Now as the car will move, reference point will move. So reference point in a given frame can change. Keep in mind. Is it clear? So when car will reach from here to here, reference point will also move. So we have to be very, very careful while defining reference point. Clear? Pause and write. Okay. Now, if I ask you, what are the parameters which will give you exact information about an object? Can you tell me? Can you think? What are the exact parameters which can give the exact information of an object? First, space coordinate. What? Space coordinate. Like if someone asks, what is the position of sir? You will say that sir is present at XYZ coordinate. The coordinate of sir is XYZ. You tell me, is it sufficient? No. Sir is at XYZ coordinate, but at what time? I am at a particular position, I am a particular place, but at what time? So it means with the coordinate, I have to tell the time. At this time, sir is at XYZ coordinate. I can change my coordinate. So you have to specify the coordinate first, and then you have to tell at what time. So you need space coordinate, you need time coordinate, and one more thing. You will tell that sir is at XYZ coordinate. You will tell that sir is at XYZ coordinate at T time. This time, sir is at XYZ. But the thing is, which is very important, from whose frame, from whose observation. The person who is observing me, that person will tell my coordinate with respect to himself. So the third important thing is observer. I can say observer is origin. Is it clear? If you keep on changing the position of observer, for him my coordinate will keep on changing. So three things are required to give what? Exact information about a particle, that is space coordinate, time coordinate, where is the particle, at what time that particle is there, and who is telling this information, who is the observer. From his frame, where is the particle? What is his coordinate? Where is this origin? He will give my coordinate. He will give my coordinates with respect to himself. I hope it is clear. Fine. Understood? Next. Next is, so we have some motion parameters. Motion parameters like distance, displacement, speed, velocity, acceleration, time. All these parameters are there when a body is doing motion. Now I am going to check out of these parameters, which parameters depend on frame dependent, which are frame dependent, and which parameters are frame independent. We'll check. This is very, very important. Okay. So for this, I want to take one simple example also. Let's say this is a car which is moving forward. Okay. And two persons, A and B, are sitting in the car. And let's say a person C is observing from outside. Let's talk about distance. This car is moving. After some time t, the car will reach here. Is it? The car will reach here. Yes or no? Fine. Understood. Now this A will reach here and this B will reach here. Is it? If I ask you, what is the distance covered by B with respect to A? So A is sitting on the car, B is sitting on the side. When they will move forward, after some time, A will reach here, B will reach here. A will say that B is not moving. Distance covered is 0. So for B or for A, B is not covering distance. But what C will see? C will see that, okay, B was here, now B reach here. So distance has been covered by B. It means distance depends upon frame of reference. Yes or no? In the same way, displacement. Displacement is what? Shortest path from initial point to final point. What about displacement? A will say, B sitting on my right. When they move to some other position, again A will say B sitting on my right. B is not displaced. Displacement of B is 0. But C will say no, B has reached from here to here. So B has a displacement. So again, displacement also depends upon frame of reference. Clear? Next is speed. A is sitting on a car, B sitting on the side. A will say, okay, B, you are at rest. Is it? Relative velocity will be 0. For A, B is not moving. But for C, C will say no, the car is moving, A is moving, B is moving. It means speed, or I can say velocity. These two depends upon frame of reference. In the same way, if the car is accelerating, so C will see, okay, B is also accelerating with car. But A will see that B is at rest. It's not even accelerating. So acceleration also depends upon frame of reference. I hope these things you have gone in class 9. We'll discuss in detail. But basics you know, acceleration is change in velocity upon time. What is velocity, speed, distance, displacement, is it? Now, next is distance between 2 points. Distance between 2 points, it's frame independent. Distance between 2 points. This will help us a lot in solving some good problems, really good problems. Like if I say, let's say in the above example in which this car was moving, let me draw it properly. This was A, this was B. I will take a point here, let's say here, on the tip of this car, I will take a point, and let's say from A, this point is 1 meter. Okay, now this car is moving. This car will move, and after some time, this car will come forward. Now this car is here. Okay. Now, again, this is our B, this is our A. Where is the point? Point is here. Now, what is distance between the A and that point? You will say, sir, distance is same, 1 meter. So, distance between A and this point was 1 meter. When this car moved, then also distance between A and this point is 1 meter. And that 1 meter is seen by B also 1 meter. That 1 meter is seen by C also 1 meter. Yes or no? Let's say distance between these two tips of my fingers is, let's say, 15 centimeter. I am moving in a bus. I show this to a person outside. What he will see? 15 centimeter. I am moving in a car, in flight. Anywhere I move, the distance between these 2 points will be always what? 15 centimeter. Whatever be the frame, doesn't matter. Doesn't matter. So distance between 2 points does not depend upon frame. It's frame independent. Car will move, then also distance will be 1 meter only for B also and for C also. Clear? Next is time. Now by saying time, most of you thought that the time will be frame dependent. Is it? Einstein's theory. Einstein's theory of relativity. You will say time is frame dependent. But see, we have to be very, very practical. We are doing mechanics. We are dealing with day-to-day life things. We will not do quantum questions, based on quantum physics. Okay, here we will have a wedge, pulley, block is falling, particle is falling, velocity, displacement of particles, center of mass of multiple particles, multiple masses, rotation, disk, sphere, all these things we have to deal with. In practical life, correct, you are correct that time is relative. But practically, in day-to-day life, the particles with which we are going to deal in this mechanics, those particle velocity will be very, very less with respect to the speed of light. So with respect to speed of light, the velocity is very, very less for the particles which we are going to deal with. So at this level, you can assume that time is what? Frame independent. Is it clear? In reality, time depends on frame. Is it? I think you all know Einstein theory of relativity. I will make a video on that as well. We'll go in depth. But right now in mechanics, you will assume time to be frame independent. From any frame, time will be same. Is it clear? Let's say this A. A is, let's say B is punching A. After every 2 seconds, B is punching A. So the person who is outside C, he will also see what? In every 2 seconds, B is punching A. In my clock, it's let's say 4 a.m. When C will see, if I show the clock, time will be what? 4 a.m. So time depends on frame. But the thing is, at this level, we have to assume it what? Frame independent. Because we are far away from speed of light, far away. So time is what? Frame independent. From any frame, the time will be what? Same. You can pause and write. Some more terms are there on which we can discuss frame dependency or frame independency. But those topics I will take when I will teach those topics. Is it clear to everyone? You can just pause and write. Clear? Okay. Now, as I told you, in kinematics, the meaning of kine is what? Motion. I discussed what is motion. Now, when a particle is in motion, matrix means maths. Multiple mathematical terms are associated with the motion. The mathematical terms which are associated are distance. That's what we have to discuss in this chapter. Displacement. Today's video will be based on distance and displacement after this. In the next lecture, I will be talking about speed, velocity, then we'll talk about acceleration, then we'll talk about jerk and all these things. Clear? You can just pause and write. And let's just start distance and displacement. Okay? So we will be starting with distance and displacement. We'll solve some numericals on this. Okay, and then we'll pack this video lecture. So this is the first lecture. I will talk only basics. Okay, in the next lecture, upcoming lectures, we will do some good problems, some advanced problems, Olympiad problems. But the main thing is the fundamentals. If your fundamentals are clear, you can do any level of problem. So first we will focus on what? Concept building, fundamental building. Clear? So distance, displacement. Let's say this is point A, this is point B, and from A to B there are 3 paths to go. These are the 3 paths to go from A to B. This path is 10 km long, this path is 6 km long, this path is 14 km long. This path name is 1, this is 2, this is 3. If I ask you, I want you all to tell, if I ask you, if I go from A to B, which of the following path can be distance? Which of the following path can be displacement? Your answer will be, sir, 1 and 3 will be distance. And second is the shortest path, second will be displacement. I know many of you told this, but this is not correct. You tell me, if I follow the path 1, how much I will travel? 10 km. So the actual path which you trace or the actual path which you travel to go from A to B, that is known as distance. So if I choose the first path, distance will be 10 km. If I choose the third path, distance will be 14 km. I can choose second path also, no? So why not second can also be distance? So first, second, third, all can be distance. Whatever path I will trace to go from A to B, that will be distance. I hope you are understanding. What will be displacement? Now, whatever path you follow doesn't matter. Displacement is always the shortest path from initial point to final point. Don't use the term between, because displacement is a vector quantity. You will say displacement is shortest path from initial to final, and the shortest path between 2 points is always a straight line. So this will be your displacement from initial to final. Is it clear? So what is distance? Distance is the actual path actual path covered in going from A to B or whatever, initial to final, wherever you are going, the actual path covered. What is displacement? Displacement is the shortest path from from initial point from initial point to final point. You have to specify initial to final, don't write between. Why? Because displacement is a vector quantity. Displacement is a vector quantity. What is the SI unit of displacement? Meter. Vector quantity, its SI unit is meter. What is distance? Distance is a scalar quantity. Distance is a scalar quantity. It does not have direction. Displacement has direction. Distance don't have direction. This also has SI unit meter. And some other units are what? Kilometer, centimeter, millimeter. These are what? Other units. So distance is actual path covered, scalar quantity. SI unit is meter. Displacement is the shortest path from initial to final point. It's a vector quantity. Okay, and displacement will be always a straight line because the shortest path between 2 points or from initial to final will be always a straight line. Is it clear? Done? Okay. Now we'll do some questions. First question is, what will be the ratio of distance to mod of displacement? See why I am saying mod of displacement? Because displacement is a vector quantity. I cannot compare scalar and vector. So I will compare distance with the magnitude of displacement. The magnitude of displacement. So this will be what? First option is more than equal to 1, less than equal to 1, more than 1, less than 1. Which option is correct? Got the answer? If you look here, if I follow path 1, what will be distance? 10 kilometer. What will be displacement? Displacement is always the shortest path from initial to final. Displacement will be 6 kilometer. Is it? If I follow path 3, distance will be 14 kilometer. Displacement will be 6 kilometer. If I follow path 2, then distance will be 6 kilometer. Displacement will be 6 kilometer. You can see distance is more or equal. So if distance is more or equal than displacement, it means its ratio will be either more or equal to 1. So answer is the first option. I hope you understood. Clear? Can I move to next part? Next question. Okay. Now in the following question, you have to find distance and displacement. You can just find the mod of displacement. Okay, and if you want, you can tell direction also, not a problem. Question number 1. A particle is going from A to B. The particle is going like this, A to B. It's a semicircle of radius R. Clear? Second question. A particle starts from A, comes back to A. It starts from A, comes back to A. Radius is R. What will be distance and displacement? Clear? Third part. A particle starts from A, goes to B. It's a quadrant of a circle. Radius is R. What will be distance to displacement? Fourth question is, this is a circle. Particle starts at A, comes to B, and this angle is 120 degree, and particle goes from A to B. A to B means starting from A, ending to B. The particle goes like this. The radius is R. What will be distance to displacement? All of you pause and try. Done? Okay. Look at the question 1. Distance is the actual path covered. You can see it's a semicircle. In one circle, distance covered is 2 pi r. It's semicircle, so distance will be half of 2 pi r, is it? So this will be 2 pi r by 2. So distance will be pi r. Clear? Next is displacement. A part we are doing. What is displacement? Displacement is the shortest path from initial to final. So this is our initial, this is our final. This will be displacement. And you can see its diameter. So displacement will be what? 2r diameter. If you want, you can write from A to B, or you can write x direction, I cap. Okay. Second question, particle starts from A, comes back to A. Initial and final point is same. Displacement will be 0. What about distance? It has covered one circle. So distance will be 2 pi r. Third question, you can see this is the actual path covered. It's 1/4 of a circle. In one circle, particle moves 2 pi r. This is 1/4 circle. So distance will be, for one circle distance is 2 pi r. It's 1/4 of a circle, 2 pi r by 4, which is pi r by 2. What about displacement? You know, always whenever you are finding question of displacement, always join initial to final. You will get an idea. So for displacement, what you will do, you will join initial to final. Can you see a right angle triangle? Yes. In which the hypotenuse is displacement. This is our radius r. This is our radius r. So what will be displacement? Displacement will be under root of perpendicular square plus base square, r square plus r square, which is root 2 r. This is the magnitude of displacement. Is it clear? In fact, you know, whenever you get a question in which it's a part of a circle, or it's a circle, or the particle is moving 2-3 times in a circle, or let's say 3 whole 1 by 4, 4 whole 1 by 7. Whenever you are solving a question in which the particle is moving on a circular track, I want you all to remember a formula for distance and displacement. This will really save your time. See, first I will talk about distance. We all know the distance is, for 360-degree, distance is 2 pi r. Is it? So for 1 degree, or I can write for 2 pi. 2 pi means what? 360 degree, same. For 360 degree, distance is 2 pi r. So for 1 degree, distance cover will be 2 pi r by 360. This is the distance cover for 1 degree. Let's say the particle is rotated by theta degree. So here distance cover will be 2 pi r into theta by 360. Remember this formula for distance. You can cross check. Here the particle has rotated by 180 degree. So you put here 180. So 180 by 360, 1 by 2, 2, 2 cancel, distance is pi r. Come here, particle rotates by what? 360 degree. 360 by 360, 1, 2 pi r. Here particle rotates by 90 degree. 90 by 360, 1 by 4, 2 pi r by 4 is pi r by 2, pi r by 2. This is you can use for distance. So here particle has rotated by 120 degree. So distance will be 2 pi r. Theta by 360, 120 by 360. 1 by 3, 2 pi r by 3. Or you can use common sense. 120 degree is 1/3 of the circle. One circle is 360 degree. So 1/3 of 2 pi r by 3. Clear? Important is displacement. What will be displacement? Displacement will be shortest path from initial to final. For displacement also we have a formula. I will show you on the next page. Let me show you on the next page. So in the previous question, the particle is going from A to B, covering 120 degree. I will say, let's say theta. So what will be displacement? Displacement will be shortest path from initial to final. Clear? Now what is this? If I ask you, what is this? You will say, sir, this is radius vector, center to circumference. What is this? This is also radius vector, center to circumference. This is R1, this is R2. Direction is different, no? So R1 vector and R2 vector. Now from here, this point, I want to come to this point. So from here to here, I have two paths. One I can go directly through R1, or which is equal to, I can choose one more path. First I will go through R2, then I will go through this. Let's call this as displacement vector. Let's call this as displacement vector. This is displacement, na? Particle went from A to B. So shortest path from A to B is your displacement. I call this as displacement vector. So if I want to go from center O to B, I can go through R1. which is equal to, I can go from O to A, which is R2 vector, then I can go from A to B, which is displacement vector. Is it? So from here, what will be displacement vector? You will say, so displacement vector will be R1 vector minus R2 vector. Now I hope you know the formula how to add or subtract vectors. Is it? So what will be this magnitude? So the magnitude of displacement will be root of, this is the way to add or subtract vectors. Here we are subtracting r mod of R1 square plus mod of R2 square minus 2 R1 R2. The angle between them is what? Theta. So cos theta. Now vectors R1 R2 has different direction, but their magnitude is same. The magnitude of R1 is equal to magnitude of R2, which is equal to R. The magnitude of R1 R2 vector is what? R. Is it? So mod of R1 square mod of R2 square minus 2 mod of R1 mod of R2 into cos theta. So from here I can write this mod of displacement is equal to under root of r square. See, mod of r1 mod of r2 is equal to radius r. So r square plus r square minus 2r square cos theta. Is it? Now from here displacement will be mod under root of, this is 2r square, this is minus 2r square cos theta. So I can take what common? I can take r 2r square common. Is it? 2r square if I take common, this is 2r square, here also 2r square, 1 minus cos theta. What is 1 minus cos theta? So mod of displacement will be under root 2r square, and 1 minus cos theta is 2 sine square theta by 2. I hope this you know from class 10th. Now 2 2s are 4, root 4 will be 2, r square and root will become r, and sine square theta will become sine theta by 2. Sine square theta by 2 will become sine theta by 2 because we have a root. So this will be 2r sine theta by 2. If you know vector, I hope you understood. If you don't know vector, no need to worry. Just go through. After some time, I will bring video on this. But I want you all to remember one thing. The magnitude of displacement when a particle is moving on a circular track is 2r sine theta by 2. I want you all to remember this. This will save your time. Clear? Pause and write. Pause and write. Done? Now look at the previous problem. What is the angle the particle has rotated? 120 degree. So what you will do? For displacement, you will be writing, okay, angle is 120 degree. So displacement will be, the magnitude will be 2r sine 120 by 2. 120 by 2 is 60. So 2r sine 60 is root 3 by 2. 2 cancel, and displacement will be r root 3. I hope you all understood. Is it clear to everyone? Fine. One more question like this, then we'll move to next part. Let's say a particle starts at A, complete one circle, two circle, then 1/4 circle. Okay. So one complete circle, one complete circle. Let me make an arrow. One more complete circle, arrow. 1, 2, and then 1/4 and comes to rest here. So basically how much the particle has covered? 2 whole 1/4 circle. Radius is r. If I ask you what is distance and displacement, I gave this formula so that you should not be confused in the formula. I gave you distance formula as 2 pi r theta by 360. See, first thing you can do with common sense, one circle 2 pi r, two circle 4 pi r, then 1/4 circle. 1/4 means 2 pi r by 4. So 2 pi r plus 2 pi r by 4. This will be your distance. And how to use this formula? In this formula you will write distance is equal to 2 pi r. One circle 360 degree, two circle 720, then 1/4 circle means extra 90. So 360, 720 plus 90, 810. So into 810 by 360. This will give you the same answer whatever you got with common sense. Clear? For displacement again you can use common sense. Sir, one circle, displacement 0, two circle, displacement 0, 1/4 circle, so initial point, final point. I will make a line like this, and displacement will be r. I will apply Pythagoras theorem, root 2r. Is it under root r square plus r square? For displacement, what you will use? 2r sine. So displacement is from here to here. One circle gave what displacement? 0. Two circles 0. Only this 1/4 motion is giving displacement. So just take what? This 90 degree. So sine 90 by 2, which is sine 45. Sine 45 is 1 by root 2. So 2 by root 2 is root 2r will be your displacement, and this will be the direction of displacement. Is it clear to everyone? I hope you all understood. Fine. Okay. Just pause and write. Next. We have a cube. Now you can do questions. They can make any question. Right? What you have to do is, distance will be the actual path covered. Displacement will be the shortest path. So you join the initial point and final point. That will be your displacement. And distance will be just trace the actual path particle is traveling. They can give particle moved 10 meter north, then took a turn of 90 degree and went 20 meter east, then came back, blah blah, whatever. You can just do. Just trace. Look at the initial final point, join them, find the displacement. And for distance, nothing, direct addition of the path they are covering. Clear? Now, one more question. This, then we will do one good question and then we'll pack this lecture. This is a cube. A particle starts from here. The particle goes, this cube of side A. Cube of side A. Particle goes like this, then like this, and then like this, and finally it reaches here. What will be distance to displacement ratio? So you know, starting here, initial point, final here. Actual path is A. Distance will be 3a. What about displacement? Displacement is the shortest path. This is the initial path. This is the final path. If you look in your room, this initial and final are something like that corner of the room and this corner of the room, which is known as body diagonal. And I hope you all know the length of body diagonal is a root 3. If the side is a, the length of this body diagonal is a root 3. If you don't know, no need to worry, a bit of vector will come. Like how? Particle has went a in I cap. If I write the displacement of the particle in vector form, particle has went a in I cap, then up plus a in j cap, then inside, this is inside, minus a in k cap. This is the vector form. How to find the magnitude? So magnitude we know, under root of x square plus y square plus z square. X square is a square, y square is a square, z square is minus a square, which is again a square, which is root 3a. Don't worry if you don't know vectors, I will make lecture on that. Right now you can just go through some book and you can just see the basics of these vectors. I hope you understood. Now last question for today. This is a ground. On this ground we have a wheel. This is a wheel. This is the center of the wheel. This is a point alpha on the wheel. Alpha. Okay. I am asking you, and the radius of the wheel is r. Radius is r. Find displacement of point alpha. Point alpha is the lowermost point on the wheel. Okay, the lowest most point of the wheel. Find displacement of point alpha when wheel rotates by first half rotation, second 1/4 rotation, third 3/4 rotation, and fourth 1/4 full rotation. 1 full rotation. All of you pause and try. I will just do part 1 and 2, 3 and 4 you have to do as a homework. It's going on fine. So 1 and 2 I will do, 3, 4 will be homework. I want you all to try. Please don't tell for the first one answer is 2R. Whenever I have given this question in class, 90% people give me answer 2R. The wheel does not rotate at the same position. You are starting your car. Suppose your wheel start to rotate at the same position. Will you move forward? No. To move forward, the wheel has to rotate like this. 1 minute, I will explain you. This is the wheel. Wheel does not rotate at the same position. Actually, the wheel rotates like this. Is it? It moves forward. It moves forward. Clear? So when this wheel will rotate half rotation, you have to tell me what is the displacement of point alpha. Pause and try. Done? See, first part. Half rotation. Half rotation means what? This is the wheel. This is the bottom point. After half rotation, this point will reach on the top. This is the bottom point. After half rotation, this point will reach on the top. But the wheel also move forward. It's not like, see, don't do this mistake. It's not like that this is alpha. After half rotation, alpha will come here. Answer is 2R. Very simple. No, wrong. You will get -1. In fact, -5. 4 you should get and -1. So when wheel will move half rotation, it will move forward also, na? It will move forward. So after half rotation, point alpha will come on the top. After half rotation of the wheel will reach forward. And the point alpha will come on the top. This is your alpha. So this was the initial point and this was the final point. Clear? Now you tell me, in one rotation, how much wheel move forward? If this is the wheel, in one rotation, how much wheel will move forward? Equal to its circumference, equal to circumference of the wheel, which is 2 pi r. In one rotation, a wheel moves forward by what? 2 pi r. So in half rotation, how much wheel has moved forward? 2 pi r by 2. It means the wheel has moved forward by 2 pi r by 2, which is pi r. So this is the initial point. This is the final point. What is displacement? Shortest path from initial to final. So join this. This will be your displacement. And how to find this? If you look, this is your diameter. This is 2r. And this is the center of the wheel, O. Center of the wheel. In this diagram, I will call it O dash. We know in one rotation, wheel move forward by 2 pi r. It means in one complete rotation, the distance between the center of the wheel at the initial position and after one rotation will be 2 pi r. Because wheel move forward by 2 pi r. And this is half rotation. So in half rotation, center to center distance will be what? Half of 2 pi r, which is pi r. You can see a right angle triangle. This is 90 degree. So displacement will be what? This is our displacement. So apply Pythagoras theorem. Displacement will be under root of base square plus perpendicular square. So you can take what? R square common. R will come out under root pi square plus 4. Clear? If they ask in the vector form, write the direction also, then what you will do? You will see, okay, this is the displacement. From the x-axis, it's making angle theta. From the x-axis, it's making what angle? Theta. So we know I can find theta by using tan theta. What is tan theta? Perpendicular by base. What is perpendicular in this triangle? Perpendicular is 2r. What is base? Base is pi r. R cancel. Theta will be tan inverse 2 by pi. So you will write displacement is r root pi square plus 4 at an angle of tan inverse 2 by pi anti-clockwise from positive x direction. Listen again. Displacement is r root pi square plus 4 at an angle of tan inverse 2 by pi, and this angle is made from which axis? X axis, anti-clockwise. I hope you understood. Fantastic. Just copy down. We'll do the next part. Rotation of wheel is 1/4. I will do 1/4. Remaining two will be homework. Fourth one is very easy. One rotation. After one rotation, it will again come down only. That is very simple. 3/4 and 1/4 you will solve and write the answer in the comment section. 1/4 I am going to solve. So for 1/4 what will happen? The wheel was here. So I am doing the 1/4 part. At the bottom the point name is alpha. In 1/4, 1/4 means 90 degree. So in 90 degree, this is the bottommost point, it will reach here. 90 degree, is it? Wheel will move forward also, na? Wheel will move forward. So wheel will move forward, and after 1/4 means 90 degree. So after 90 degree, the point alpha will be here. Is it? It will rotate like this. Rotate like this. So again, initial point, final point, this is our displacement. How to find out this? So in one circle we'll move by 2 pi r. So in 1/4 circle wheel will move by 2 pi r by 4. 2 pi r by 4 means from center to center the distance will be, this distance will be 2 pi r by 4 means pi r by 2. Is it clear? Now this is your radius. This is your radius. So what I'm going to do, you can see displacement initial to final. This is our displacement. That's what we have to find out. What I will be doing, what will be this? Let me change the color. What will be this? This is R. This is also what? R. And what will be this? What will be this yellow line? This is pi r by 2 and this is R. This part is what? R. So this remaining part will be what? Pi r by 2 minus R. Clear? So if you look at your triangle, it's like this is our displacement. Is it? This is what? Pi r by 2 minus R. And what is this? This is our R. So displacement will be, apply Pythagoras theorem, under root of R square plus pi r by 2 minus R whole square. And to find out angle, same thing we will do. Tan theta is equal to perpendicular by base. So R divided by, I can take R common from here, or you can just write pi r by 2 minus R. And from here you can take R common and you will be getting pi by 2 minus 1. R cancel out, and from here theta will be tan inverse 1 upon pi by 2 minus 1. If you want, you can solve it further, no issue. So your answer will be, and what is theta? This is theta, na? Tan theta is perpendicular by base, perpendicular by base, perpendicular by base. And so what you will write? Displacement is root over R square plus pi r by 2 minus R whole square at an angle of tan inverse 1 upon pi by 2 minus 1 from positive x-axis in anti-clockwise sense. Is it clear? Two more questions are there. You can try. Any doubt, write in the comment section. Okay, so all the best. This was a very basic lecture. In the next, we will be discussing with speed, velocity, in which I will take instantaneous, average, and there a lot of differentiation integrations will come. No need to worry. We'll start from very basic and we'll go to very advanced. Is it clear to everyone? So all the best. Okay, just keep on doing hard work. Be consistent. Bye.